Okay, so today we've got two more segments in triangles. These are going to be the medians and altitudes. Today's assignment is also going to ask you to identify not just median and altitudes, but the other things that you've learned along the way. So we're going to be adding these into the mix. Today the medians and altitudes are always going to be coming from vertices, excuse me. So we're going to go ahead and take a look at the first one, which is a median. A median is going to start at the vertex of a triangle. Guys, it's got to start at one of the points on the triangle. It cannot start anywhere else. It's going to start at the vertex of a triangle, and it's going to go to the midpoint of the opposite side. Guys, if it's a midpoint, then it is going to cut that segment in half, so that this side is going to be congruent to this side. So if I ask you, what is the median in this picture? Because they're going to ask you, name the median. What's the median here? E is the point. What's the segment? AE. AE is the median. AE is going to be your median. And then the two segments that are going to be equal, their measurements, it's going to be BE is going to have to be, without the bar, is going to be equal to the measurement of BE is going to be equal to the measure of CE. There you go. Perfect. So guys, on these problems, every time you have a median, you're going to set them equal to each other. Every time. Okay? Median, set them equal. Median, set them equal. If you've got a median, set them equal. Okay guys, so let's do a problem with this. EG is a median. If it's a median, this side is going to be congruent to this side. That's the first thing you need to mark. It tells you that you're going to find X and DF. Oh, before we start, let's talk about that DF, because someone is going to mess us up. This is like the question Landon asked. It was a very good question. Guys, DF is going to be from here all the way over to here. It is not just one of them. It is the whole thing across the bottom. So I want you to see that we're finding X and then we're finding DF. It also tells us that DG is 4x minus 1 and that GF is 2x plus 5. And what did we say about those two sides? Every time you have a median, set them what? Equal. Set them equal. So here we go. 4x minus 1 has got to equal 2x plus 5. The key, some of y'all still having problems deciding what to do when you're solving algebra problems. Move the variables to one side. If you've got one that's smaller, move it first. Since there's variables on both sides, move that one first. That makes it 2x minus 1 is equal to 5. Now that all my variables are over here on the left, I want my numbers to go over to the right, so I add 1. 2x is going to be equal to 6. Divide both sides by 2, and x equals 3. Now, that's the first part of our answer, is that x equals 3, guys. But there is another part to the answer. I've got to plug back in and find out the length of df. So I'm going to plug it back in. It doesn't matter which one you plug it into. Okay? I'll plug it in here. 4 times 3 minus 1. Guys, that'd be 12 minus 1, which is 11. And if it's 11 on this side, then it's got to be 11 on this side, which means when I'm answering DF, how long is DF? 22, because it's the 11 and the 11 added together to get this whole length all the way across the bottom, which is 22. Does anybody have a question about why I got 22, why I put them together, or anything about it? Okay, yep.
No, but I put 3 into the 2x plus 5.
Okay, so 2 times 3 plus 5 is going to be 6 plus 5, which is also going to be 11. It doesn't matter which side you plug it into, guys. Thank you for saying something, because you can't, arithmetic will mess you up. Use your calculator. Remember, the EOC, you can use the calculator on the whole thing. There's not like last year where you had a part without and a part with. Everything you can use the calculator on. Alright? And it's all in one day this time. Yay. Okay, here we go. So, for the next one, we're going to be talking about altitudes. Altitudes are kind of unique because it's the only one that deals with just an angle. An altitude goes from the vertex, that's the key, from the vertex it's going to go to the opposite side, and it's going to be perpendicular to it. Guys, if it's perpendicular, what do you have? Right angles. You're not going to have just one right angle. You're going to always have two. It may only show one, but there's always two. If there's one right there, there's going to be a second one. Okay? And if you're going to be dealing with right angles, you're going to be dealing with things being equal to what? Someone said it. 90. It's a right angle. It's going to be equal to 90. That's the whole idea behind this. Just like I told you, when you're doing medians, you set things equal. When you deal with altitudes, you set things equal to 90. Every single time you're going to be setting it equal to 90. Okay, here we go. First of all, if I needed to name the altitude here, what's the name of the altitude here? Ooh, it's AE. Do y'all see that it kind of moved over a little bit? I don't know why the E is over here, but it's supposed to be over here. AE is going to be your altitude. The reason I want you to actually name it is because that's one of the things we do on the homework and on the rest of the notes. You're going to have to name different pieces, so it's important you can see it. Okay, the next thing is going to be that you're going to have to go to this triangle. It tells you it's an altitude. If it tells you it's an altitude, mark first thing that these are right angles. First thing, altitudes make right angles. It also tells you that angle KTJ, this angle over here, is going to be 7y plus 6. And what am I going to do with that 7y plus 6? Set it equal to 90. Good. Set it equal to 90. Every time, guys. If it's an altitude, set it equal to 90. Here we go. Minus 6 minus 6. 7y is equal to 84. Divide by 7. Hope that it divides evenly. Yeah, because 7's an ugly denominator, so if it doesn't, what's it divide to, guys? 12. There we go. Okay. Concerns, questions, anything so far? Okay. So, then the next thing, got one altitude, one median problem. So, on this first one, it tells you it's a median. If it's a median, these two sides are going to be equal. It tells me that DG is 2x plus 11. It tells me that GF is 5x minus 4. It also tells me that I'm trying to find x, and I'm trying to find DF, which is the length of the whole thing. Be careful. Length of the whole thing, guys. So in this case, what am I going to do with these two amounts? Equal. So 2x plus 11 is going to equal 5x minus 4. How do I know that? Because medians are in the middle. They're equal. They create two equal parts. So from there, you're going to minus 2x minus 2x. That makes it 11 equals 5x minus 2x would be 3x minus 4. You're going to add 4 because all your variables are now on the right side, so you need your numbers to go to the left. It's going to make it 15 equals 3x. Divide by 3. And 5 equals x. Okay, from there, what are you going to do with that x equals 5, or 5 equals x, however you do it? Plug it back in. Does it matter which one you plug it into?
No.
No. So I'll plug it in the one on this side this time. 5 times 5 minus 4 would be 25 minus 25 minus 4, which is 21. Just so you can see it on the other one. 2 times 5 plus 11 would be 10 plus 11, which is also 21. So what's DF, guys? Whoa, 42. Because 21 plus 21 is 42, and x was 5. Just because you're going to have to fill in the answer blanks on the test, I want you to make sure you put those answers with them wherever they're asking. Okay, last one of these. Alright, before we move on, is going to be an altitude. If it's an altitude, what do I draw on here? Right angles. Since it's right angles, we're going to have 4y plus 8 right here in this corner next to this right angle. So I set that 4y plus 8 equal to 90. equal to 90. I minus 8 minus 8. I think this is the one that turns out to be a decimal, so you may need a calculator for this one. 90 minus 8 puts you at 82. Divide by 4, divide by 4. Yeah, it's going to be a decimal, guys. Tell me what you get once you divide it.
20.5.
To 0.5?
Yeah.
Okay. 20.5. Does anybody have a question, a concern? Can you get decimal answers? Yes, they're normal, guys. The decimals are okay. You can have a decimal. Now, if it's an ugly decimal, you got to leave it as a fraction. You can't give me like 0.732987 and it never ends and never even repeat. If it repeats, don't give it to me. Just, guys, if it ends, if it's a nice decimal, you can give it to me. Otherwise, you got to go back and leave me as a fraction. Okay, guys. From there. Anything? Anybody still ready? Okay. Last thing we've got to do is go through and name these. They've got 2 pages, 2 slides about naming things. The first one is actually, to me, the hardest. This is a very visual part. The way that I'm going to do this is I'm going to trace over the triangle they're talking about, and hopefully it'll make it easy for you to see. I suggest you sketch them off to the side if you need to do that, but I would just watch up here for now so you can trace this and see what we're doing. So the first one I'm going to do is I'm going to trace it in this blue right here, not quite that thick. Here we go. So the triangle we're talking about is MQO. MQO. This is the triangle. Okay? We're looking for an altitude. I need an altitude for this. So it's got to be right angle. What could work, guys? MQ would absolutely work. That's too big. MQ. What else could work? Not Q. Well, you could absolutely do QM. It's just backwards. I would absolutely take that. But there is another piece, guys, that could be called the altitude. It could be QO or OQ. Either way. Okay. As long as it's at a right angle, guys, and it touches one of the vertices, then it's going to be your altitude. So let's draw another one. So the next one. Let's make this one pink. The altitude for triangle MQP. MQ, oh, it's this little one right here. Okay, 2 possible answers on this one. I gotta take the size of my pencil down. What would work? MQ again. It's a right angle, so you're probably going to see that one several times. And then what else would work, though? QP would also work. Perfect. Okay, so that's the altitude for that one in pink. Does anybody have a question on that one? Okay. Oop, that wasn't the right button. Sorry.
It don't matter what order you put it in?
Not at all. Could be PQ, be perfectly fine. Could be QM, that would work also. Good question. No correspondence, so order does not matter. Okay, the next one we'll do the triangle MOR, and we've got 2 of them on this one, so we'll do MOR, and we will make it, let's see, green. Okay, so MOR is going to be, here we go, oh, it's the big one, right? It's the whole thing. MOR. So it's this triangle, and I need a median. It's got to go from one of the vertices to the opposite side, and it's got to cut it in half. What works? It's going to start here. It's going to go to the opposite side, and it's going to be congruent. So that's going to be RN. RN or NR. Doesn't matter. Do you see it's the only side on that triangle where it starts at a vertex and goes to the opposite side where they're marked congruent to each other? It does on this triangle over here. See how it's got one that goes in the middle, but does it start at a vertex? Is Q one of the vertices? Not of that triangle. That may be for a different triangle, but not for that one. What about an altitude for the green triangle? An altitude for this one? There's only one. Okay, if it's got to have a right angle and it's got to start at a vertice, what would it be? MQ would be the only one that works. Guys, do you see it starts at a vertice? It's got a right angle The only points that would work would be M, R, or O. Those are the only vertices in that triangle. Okay, let's get one last color. Let's see, get the eraser. The last triangle we're going to look at is the triangle. Let's see. Let's make it orange. So, median of MQR. MQR. I need to start at one of the vertices, either M, Q, or R, and go to the opposite side, and it be congruent. QS. It's got to be this one right here, guys, because this is the only side that's on the orange one that's congruent. So it's going to be QS. Or what? Or SQ. Perfect. Okay, does anybody have any questions, concerns, anything about that one? Okay, guys. So last thing real quick is going to be deciding, this is one of the things you have to do on your homework, is it a median, is it an altitude, or is it neither? So here we go. So starting off with, guys, this one throws people off every time. This is going to be a problem where you have it from a vertex to the opposite side at a right angle. So what's that going to make it? Altitude. Guys, just because it's outside doesn't mean it can't be an altitude. What's the other word for altitude? Does anybody know what that is? This is the altitude of the triangle. It is the height of the triangle. That formula, 1/2 base times height, there's the height, the altitude. Okay, sometimes it's outside the actual triangle. Okay, for the next one, it's got these two angles marked congruent. Does that make it a median, altitude, or neither? What would this one be called? It's not in the list, but what would it be called? Angle bisector is correct. It is an angle bisector. How do I know that? Because the angles are congruent. That's the only thing marked on there. Angle bisector. It's not one of the choices, but that's what it would be. Okay, for the next one, it starts at a vertex, goes to a right angle on the opposite side. What's that going to make it? Guys, what starts at a vertex and goes the turn the paper if you need to. That is an altitude. There you go. Okay, you're welcome. That is an altitude. And the last one, guys, it goes from a vertex, it goes the opposite side, it hits right here with these two parts being congruent to each other. That makes it a what?
Median.
Median. Now, I want to add something to this. Watch. Watch. If I added a right angle symbol right here, don't listen. This is just me adding something to it. What would this change into? It's no longer a median, it's a what? No, it's an altitude and a median put together. What is an altitude and a median put together in these kind of triangles? It is a perpendicular bisector. Ooh. In an isosceles triangle, if you got a right angle and it's split, it becomes a perpendicular bisector. I just want to put that because that's one of those tricky things they'll show you on your worksheet. Okay, guys, let's go ahead and put this in our folders. Let's go ahead